Hello and welcome back, guys. So today we will be doing logarithms, but this time we will be doing the difficult questions. If you struggle with these questions, you can make your concept by watching the video lecture uploaded on logarithms, and then you can practice on the easier questions video uploaded the day before. Okay, so now let's begin. So solve the simultaneous equation. 1 plus. Okay, so we have these two simultaneous equations and we need to solve it. Okay, so in simultaneous equations the rule is simple. I can see that there are variables x and y. Okay, x 6x and here y. So we have to eliminate the logarithmic form and bring it to simple x and y form. Okay, so let's first pick up the equation 1. Okay, this equation over here. Okay, so it would be 1 plus 2 log of x to the base 5 is equal to log of 7y to the base 5. I can see that the bases are equal over here. That means that they can be added or added along. Okay, so it would be 2 log 5x minus log 7y to the base 5 equals to minus 1. I have brought this 1 over here. Okay, now there is a minus sign in between, but first of all we need to see the coefficients. Okay, over here there's a 2 coefficients, so what we will do is that we will do it like this: 5x square minus log of 7y to the base 5 is equal to minus 1. Okay, now I can simply subtract it. Okay, and that will give me log of 5x square over 7y to the base 5 is equal to minus 1. Okay, now that I have this, I can simply now that I have this, I can convert it into exponential form. Okay, and that could be done by shifting this answer into the power of 5 and this underneath. Just let me just show it to you over here. Okay, so it would be 5 power minus 1 is equal to x square over 7y. That way we have eliminated the logarithm log, you can see. So now it is in that form. Okay, you can further simplify it by saying that 5 power minus 1 is equal to 1 over 5. So it could be x square over 7y is equal to 1 over 5, right? Okay, so this is our first equation. Okay, I can write it as this equation 1. Now let's see the second equation. Okay, so that is log of 7. Let me just do it with the white pen. Log of 6x minus 1 to the base 7 is equal to 1 plus log of y to the base 7. The drill remains the same. Okay, so we need to first shift the logarithm terms to one side. I will bring it over here. Okay, so what will happen is that log of 7 6x minus 1 minus log of y to the base 7 is equal to 1. Okay, and now you will because there are minus sign between, so the powers will divide. Okay, 7x minus 1 over y is equal to 1. Now I'll shift it into exponential form. Okay, so the 1 would become the power of 7. So 7 power 1, which is actually 7, is equal to, and this will come in the place of 1. Okay, so it would be 6x minus 1 over y. Okay, so this is our second equation. 6x minus 1 over y is equal to 7. Okay, these are our two equations. Okay, so now we will just simply simultaneously solve it. We can do it by substitution method. Let me show you what that means. First of all, let me make the y the subject over here. You can make x or y the subject of from any of this equation, from this equation or this equation. I'll make the y the subject from equation number 2. Okay, so what will happen is that 6x minus 1 is equal to 7y, and now y is equal to 6x minus 1 over 7. But wait a minute, I can see over here that here as well we have 7y, right? and here as well we can have 7y. So let me just bring that 7y as it is. Okay, so if we simplify this equation and bring the 7y in the numerator, we can have 5x square is equal to 7y. Okay, so that means that this 7y is equal to this, and 7y is also equal to this. So that way I can just simply, so now we have 7y on both sides. So now what we will do is that we will equate the other two sides. 5x square is equal to 6 minus 1, because both are 7y. That means that 7y is equal to 5x square, and 7y is also equal to 6x minus 1. So that means that 5x square would also be equal to 6x minus 1. Okay, so what we will do over here is 5x square. Just a second. Okay, 5x square is equal to 6x minus 1. 5x square minus 6x plus 1 is equal to 0. Now we can simply solve that in a quadratic way. Okay, so what we will do is 5x square minus 5x minus x plus 1 is equal to 0. 5x x minus 1 minus 1 x minus 1. You can do it on your calculators as well. Okay, so what will happen is 5x minus 1 is equal to 0, x minus 1 is equal to 0, and that x would be equal to 1 over 5, and here x would be equal to 1. So these are the two values of x. Now let's solve for y. Okay, so we saw that y is equal to 7y is equal to 5x square. We'll just write it over here. 7y is equal to 5x square. Okay, so that way what we can do is now that we can put the value of both values of x over here. So 7y is equal to 5 into 1 over 5 square, or in the other case it would be 7y is equal to 5 into 1 square. Okay, so what the answer would be, 7y is equal to 5 over 25. It would be 1 over 5. Okay, and next would be y is equal to 1 over 5 divided by 7. 1 over 5 divided by 7, it could be 1 over 5 multiplied by 1 over 7, and that would be y is equal to 1 over 35. Okay, so this is the value of y. Next up we have y over here, so it would be 7y is equal to 5, and y is equal to 5 over 7. Okay, so now that we have these two values, we need to then see if both these values are valid for the equation. Okay, so the values we have are 1 over 5, 1 over 35. Let me just write it over here. The x would be, if the x is 1 over 5, and the y is 1 over 35, whereas the other value is, if the x is 1, then the y is, if x is 1, then y is 5 over 7. Okay, if x is 1, then y is 5 over, okay, wait, and x is 1, y is 5 over 7. Okay, now we have to see if both these values also fit with these equations. Okay, so you will you can do it on your calculators, or either way, what you will do is that you will put these values of first this value in both the equations, then this value in both the equations. If the answers are coming correct, then these are the values, because sometimes what happens is that, for example, if I have let me give you an example. Yeah, so let's say if I had minus 1 over here, so what would have happened is that it would be log of minus 6 minus 1 to minus 7 to the base 7 is equal to 1 plus log y, which is 5 over 7 to the base 7. Okay, so now I can see over here is that log of 7 minus 7 to the base 7 does not exist, because this cannot be a negative number, right? So that way it won't be correct. But over here you can see it on your calculators on your own as well, but I have seen that both these answers are valid. Okay, so you will leave both the answers on your exam papers. If one of them is not valid, you would just write NA next to them. For example, this is not valid, you can write NA, and you can just box this answer. Okay, but in this case both are valid, so you will leave both of them. Okay, let's move on to the next question. Okay, so this is the next question. Okay, so this is a very interesting question, you will enjoy this question. Okay, so find the value of k for which 3x is equal to e power kx. Okay, so we have to find the value of k over here. K is our variable. Okay, just a second. Yeah, so if k is our variable, what we will do is 3 power x is equal to e power kx. We need to solve for k and find the value of k. So let me just analyze this question real quick. Okay, so I can see that both the variables, that x and the kx, both are in the exponential form, like in the powers. Okay, so if we want to bring these powers down, what we will do is that we will take logs on both sides. Okay, so if I take log to the base e, okay, log to the base e, log of 3 power x to the base e, and log of e power kx to the base e. This can also be written as ln 3 power x is equal to ln e power kx. Okay, so both are the same things, but this is better to write because it is shorter, and log of e is generally written as ln. This can be written both ways, but the ln one is better to write, because that way the log e is first of all longer, and second of all log e is basically equal to ln, just as log of base 10 is equal to lg. Okay, so now what we will do is that we will this is basically called natural log. Okay, so now that we know that if we break it down, we can see that there is log of 3 to the base e, and then we have a power x. So this power x could be separated by bringing it down. Okay, so what will happen is x ln 3 is equal to, over here we also have this power, this as power, so this would also be brought down. It would be kx ln e. Okay, so now I can see that ln e is basically log of e to the base e. Okay, so that would be equal to 1. Okay, so whenever we have like log to the base 4 or log of 5, these are all equal to 1. Similarly, log of e to the base e is also equal to 1. So what will happen now is that this would become 1, so it should not be written. Okay, so it would be kx is equal to x ln 3. As we can see that x is being multiplied on both sides, we will divide x with both sides. What will happen is over x, it would cancel out, so it would be k is equal to ln 3. This is the value of k. You can put it on your calculators as well and find the exact value, but I will just put it as it is, because both ways are correct. If it is not written that you need to give your answer in 3SF or 2SF, you can write it in either way, in exact form as well. Okay, so question 19 is solve the equation e power x plus e power 2x is equal to e power 3x. Okay, this seems to be an interesting question. 2x is equal to e power 3x. So now we need to see that what e basically means. What I can do is that I will use the same strategy. I will take ln on either side. Okay, yeah, or else what I can do is that I can write it as e power x plus e power x whole squared is equal to e power x whole cubed. Okay, so this way we have this e power x common in the whole equation. Let us just make it equal to, let e power x be equal to y. Okay, so what will then happen is y plus y squared is equal to y cubed. Okay, so now what I will do is that I will divide the entire equation by y. Okay, so if we divide this side by y, what will happen is, if we divide, because there is a plus in between, we will can divide the separate terms with y as well. Okay, so the end result would be 1 plus y is equal to y squared. Okay, so y squared minus y, I will be bringing the entire thing on one side, minus 1 is equal to 0. Now you can solve this quadratic equation. So the answer would be, let me just do it, because it can't be solved that way, so I will have to apply the quadratic formula. So y is equal to minus b plus minus square root b square minus 4ac over 2a. Okay, so basically a is this term, the 1 over here, b is this minus 1, and c is also minus 1. Okay, so what will happen is minus 1 would be plus 1, 1 plus minus square root minus 1 squared would be 1, minus 4 into 1 times minus 1, and it would be 4, 1 plus 4 over 2 into 1. So it would be 1 plus minus square root 5 over 2. Okay, so this is the value of y. So now we have to see that what we supposed y to be equal to. We suppose that y would be equal to e power x. Okay, that means that these are not the values of y, these are actually the powers of e power x, the answers for e power x. So e power x is equal to 1 plus minus square root 5 over 2. So now I can take ln on both sides. Ln of e power x is equal to ln of 1 plus square root 5 over 2, and either on the other side I would have ln e power x is equal to ln of, just put it in bracket. Okay, ln of 1 minus square root 5 over 2. Okay, I don't know if the answer comes out to be negative, but this is the working. If the answer, for example, over here comes out to be negative, then there would be a math error. You would just write NA over here. Okay, and you will just solve this equation. Okay, which is most probably the case. And over here what will happen is that, as we have ln e, which is essentially log of e to the base e, so that would be 1, and x would become come down, and x would be equal to ln 1 plus square root 5 over 2. Okay, you can add it as it is, or you can convert it into the other form. It's entirely up to you. Okay, that is it for this question. Let me just do another question. Okay, so here we have our last question for today. Okay, so what is it? That use logarithm to solve the equation 3 power x is equal to 10 power 6, giving your answer correct to 3 SF. Okay, and hence determine the number of integers satisfying the number of integers n satisfying this. Okay, so first of all we need to solve this equation. 3x is equal to 10 power 6, 3 power x is equal to 10 power 6. So it would be simply done by LG. Okay, LG on both sides, LG 10 power 6. Okay, so x would be LG 10 power 6 over LG 3, because I brought this x down, so now it is a multiple. Okay, and LG 3 would be, go over here, this LG 3 would be divided on this side. Okay, so what will happen is that this LG 3 would divide on this side, so the denominator would be LG 3. Okay, I can see that I have taken LG, so that means log of base 10. So when we have log of base 10 and 10, that this means that it would be 1. So I can just bring the 6 down, and 6 multiplied by 1 is equal to 6. So the numerator would become x is equal to 6 over LG 3. Okay, and the answer would be 12.6. Okay, So that is the value of x. Yeah, so that is the value of x. So now let's see the other part. Okay, the other part says that hence determine the number of integers n satisfying this equation. Okay, the number of integers that are satisfying this equation, this inequality. Okay, so we have 3 power n in between, and we have 10 power minus 6 and 10 power 6 on the other two sides. Okay, so we need to see that what does 10 power 6 equal to. Okay, so 10 power 6 is basically equal to 1 million, right? And 3 power n, which is 3 power 12.6, that would be equal to, just a second. Okay, so 3 power 12.6 would be equal to 1027, but we don't need to go in these such large numbers. What we can do over here is that we can make it simple, this inequality simple, by simply just doing it like the previous part. Okay, so as we can see that the previous part says that 3 power x is equal to 10 power 6, right? So then we can just substitute this with x. So 3 power n this time is equal to 10 power 6, and then n would come out to be 12.6. Okay, that means that it means that we have 12.6 on this side. Okay, and over here we have the 6. Okay, 6 and minus 6, no, sorry, so we have 12.6 in the middle, and we have 10 power minus 6 and less than on the one side, and 10 power 6 on the other side, which means that there would be 12.6. That means that there would be 12 numbers behind this. Okay, because there are it is less than 0 basically, because when we have n, then the other would be 10 power 0, and then it would become 1. So okay, so we would have 12 numbers on one side and 13 numbers on one side. Okay, so 13, and so we have a plus in between, and that would be 25 numbers in total. So that is it for this question and for this video. Thank you for watching. Bye bye.